Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna talk about variance and covariance on random variable. Before that, let we introduce ourselves. My name is Sigma Zuber and my friend is Anastasia Lena. First, the most important measure of variability of a random variable x is obtained by applying gx equal to x minus mu square. The quantity is referred to as the variance of the random variable x or the variance of the probability distribution of x and is denoted by variance x or the symbol sigma 2x or simply sigma 2 when it's clear to which random variable we refer. The variance of x, there is definition 4.3. Let x be a random variable with probability distribution fx and mean mu. The variance of x is, if x is discrete, sigma square equal to ex minus mu square. Sigma from x minus mu square fx. And if x is continuous, sigma square x mean mu square equal to integral from minus infinity till infinity x minus mu square fx dx. The positive square root of the variance sigma is called the standard deviation of x. And then there is example. Let the random variable x represent the number of the phone number that usually a lot of people always use. Find the variance of x with the following probability distribution of x is, and there's the table. First we compute mu is 0 times 3 over 10 plus 1 times 2 over 5 plus 2 times 3 over 10, and the result is 1. And now ex square equal to 0 times 3 over 10 plus 1 times 2 over 5 plus 4 times 3 over 10, and the result is 8 over 5. Therefore, sigma square equal to 8 over 5 minus 1 square is equal to 3 over 5. So the variance of x is 3 over 5. And the next is the variance of random variable x theorem 4.2. The variance of random variable x is sigma square equal to ex square minus mu square. Discrete probability distribution, the formula is sigma square, sigma from x square fx minus mu square equal to ex square minus mu square. And the formula of continuous probability distribution is sigma square equal to integral from minus infinity till infinity x square fx minus mu square dx equal to ex square minus mu square. And there is the example. Farmer 3 always sell his vegetable harvest to the market. The vegetables produced by farmer 3 varies. If is a random variable of the type of vegetable that farmer 3 will sell, find the variance of with the having probability density. And the solution is calculating ex and ex square. We have mu equal to ex equal to integral from 1 until 2 x square minus 2 dx equal to 1 over 3, and ex square equal to integral from 1 until 2 x power 3 minus 2x dx is equal to 3 over 4. Therefore, sigma square equal to 3 over 4 minus 1 over 3 square equal to 23 over 36. So the variance of x is 23/36.
Okay, so next we talk about variance of the variable gx, and in here we have theorem 4.3 that say let x be a random variable with probability distribution fx, and the variance of the variable gx is, so in here we just change the function fx to be gx. Okay, so in here we have if x is discrete and if x is continuous. The formula of if x is discrete is the sigma gx square equal a gx minus mu gx square equal sigma x gx minus mu gx square times fx. And in here we have if x is continuous, the formula is sigma gx square equal a gx minus mu gx square equal integral from minus infinity until infinity gx minus mu gx square fx dx. Okay, so to understanding this theorem, we have example questions. So calculate the variance of x, where x is a percentage of 3 students' comprehension test in a subject mathematics with the following distribution like this. So in here we have x from 1 until 3, and we have fx if x equal 1, the fx is 0.5, and if x equal 2, the fx is 0.2, and if x equal 3, the fx is 0.3. Okay, so how to calculate the variance of x? So first, the solution is we must to find the mean of the random variable of x squared. So x squared this from the function. So the mean of the random variable x squared is mu x squared equal a x squared equal the sigma from x until 1. From x equal 1 until 3. X squared times fx. In here we have 4. So 4 from x squared times fx. If x equal 1 until 3, so we must to change the x of x squared times fx. We must to change x with x equal 1 until 3. So 1 squared times fx if x equal 1 is 0.5 plus 2 squared times fx if x equal to is 0.2 plus 3 squared times fx if x equal 3 is 0.3. And we calculating and we have 4. Okay, next we must do using the theorem before. So because this is discrete, we must do using the theorem that if x is discrete. So mu x square equal a x square minus mu x square equal a x square minus 4 square. So 4 from the value of the mean of the random variable before. So x square minus 4 square, we have a x power 4 minus 8 x square plus 16, and then equal the sigma x equal 1 until 3 x power 4 minus 8 x square plus 16 fx. So like before, we must to change x with 1 until 3. So 1 power 4 minus 8 times 1 square plus 16 times fx if x equal 1 is 0.5 plus 2 power 4 minus 8 times 2 squared plus 16 times fx if x equal to is 0.2 and plus 3 power 4 minus 8 times 3 squared plus 16 times fx if x equal 3 is 0.3. And in here, after calculating, we have 12. So the variance of gx equal x squared is 12. Okay, we have example for continuous. So let be a random variable with density function fx equal to x if x less than equal 1 and greater equal 0 and 0 is elsewhere. Find the variance of the random variable gx equal 3x plus 2. So gx equal 3x plus 2 is the function, okay? And we have the solution. First, we must to find the expected value of gx equal 3x plus 2. So the formula is a 3x plus 2 equal integral 0 until 1 3x plus 2 times 2x dx. So 2x plus 2 from gx and 2x from fx dx. Okay, equal integral 0 until 1 6x squared plus 4x from 3x plus 2 times 2x dx. Integral 1 over 3 6x power 3 plus 1 over 2 4x squared dx. And we have 4. And next we must do using the theorem 4.3 before. We have sigma 3x plus 2 square equal a 3x plus 2 minus 4 square 4 from the expected value before equal a 3x minus 2 square 3x minus 2 square integral 0 until 1 3x minus 2 square times 2x dx. 3x minus 2 square we have times 2x we have 18x power 3 minus 24x square plus 8x dx. So in integral from that is 18 times 1 over 4x power 4 minus 1 over 3 24x power 3 plus 1 over 2 8x squared dx, and we have 1 over 2. So the variance of gx equal 3x plus 2 is 1 over 2. Okay, we have covariance in two random variables. We have definition 4.4 that say let x and y be random variables with joint probability distribution fxy. The covariance of x and y is sigma xy equal a x minus mu x times y minus mu y equals sigma x sigma y x minus mu x times y minus mu y fxy. The formula if x and y are discrete. So if x and y are continuous, the formula is sigma xy equal a x minus mu x times y minus mu y equal integral from minus infinity until infinity integral again minus infinity until infinity x minus mu x times y minus mu y xy dx dy. We have example from covariance. Okay, the example is in a Voila face shop. There are two different types of faces that are prone to breaking after delivery to customers. The white color face as X and the black color face as Y. So the data was taken randomly from several customers who called to us for compensation, and the following is the joint probability distribution. So in here we have the table of joint probability distribution. So we have X and Y in here. The X and Y is from 1 until 2, and we have GX for X and HY for Y, and X and Y equal 1. Okay, so in here we have the solution of that problem. So how to calculate the covariance of the random variable x and y? So first we must to find the expected value of gxy equal xy. So in here we have axy equal sigma x equal 1 until 2, sigma y equal 1 until 2, xy fxy. Just compute the number. For x equal 1 is 1 times 1 times 0.20 plus 1 times 2 times 0.25 plus 2 times 1 times 0.20 plus 2 times 2 times 0.35 equal 0.20 plus 0.50 plus 0.40 plus 1.40 equal 2.5. In here we have expected value of gxy is 2.5. Now find joint discrete distribution. We must to find mu x and mu y. Mu x equal sigma x equal 1 until 2 xgx equal 1 times 0.45 plus 2 times 0.55. We have 1.55. And mu y equal sigma y equal 1 until 2 hy equal 1 times 0.40 plus 2 times 0.60 equal 1.60. Therefore, sigma xy equal axy minus mu x times mu y. So in here we have the expected value before is 2.5 minus mu x times mu y. Mu x is 1.55 times 1.60, and in here we have 0.02. So the covariance of x and y is 0.02. Okay, next, covariance of two random variables x and y. In here we have theorem 4.4. The covariance of two random variable x and y with means mu x and mu y respectively is given by sigma xy equal axy minus mu x mu y. So first, joint discrete distribution, we have mu x sigma x x f x y, mu y sigma y y f x y, and sigma x sigma y f x y must be 1. 2. Joint continuous distribution. We have sigma xy equal a xy minus mu x mu y minus mu y mu x plus mu x mu y equal a xy minus mu x mu y. And the next we have correlation coefficient of x and y. There is a scale-free version of the covariance called the correlation coefficient that used widely in statistics. And in here we have definition 4.5. Let x and y be random variables with covariance sigma xy and standard deviations sigma x and sigma y respectively. The correlation coefficient of x and y is, we have formula is rho xy equal sigma xy over sigma x and sigma y. Okay, so maybe that's all for the material of variance and covariance on random variables. Thank you and see you in the next video.